In this video, I'm going to talk about the basics of some parabolas, which is the next conic section that we're going to talk about. You've done parabolas in Math 2. We've dealt with parabolas a little bit in Math 3. But the parabolas we're going to deal with here are not necessarily functions. And so this is where, if you'll notice that we will have parabolas that are concave up and concave down. That's the standard functions that we've been dealing with. But parabolas can also be concave right and left. These are non-functions, but that doesn't make them, non-parabolas. They're still parabolas, they just aren't functions, and that's okay. So let's talk about something that you probably did not necessarily know about about a parabola, and that's the definition. A parabola is the set of all points on a curve such that the distance to a fixed point off the curve, that point is called the focus, okay? And the distance to a fixed line off the curve, that line is called the directrix. Directrix are equidistant. So when we look at the graph of a parabola, there are certain features that we want to talk about. The actual black curve, right? This curve is the parabola. That's what we're used to. That's the curve. Now, there are pieces that are attached to this we want to talk about. So the little green dot in the middle, that is that focus point, all right? And then the red dotted line, this is the directrix, okay? As soon as I learn how to spell directrix. All right, so here's the deal. If I pick, let's say, this point right here, it's any point on the parabola, the distance from that point straight down to the directrix and the distance from that point to the focus are equidistant, meaning they're equal. Now, our picture may not look perfect, and that's okay, but the definition of parabola says that those two red line segments I just drew would be equal. Now, I'm going to go ahead and take those out just so I can put in a few other pieces of information, all right? The distance from and I'm going to zoom in a little bit here. So the distance from this point, by the way, this lowest point here, this is called your vertex, all right? So the distance from the vertex to the focus and the vertex to the directrix are equidistant, right? It's any point on the parabola that works for, all right? So this little distance right here, the distance from the vertex to the focus is called P. That is I'm going to put this off to the side because it's kind of, running into some space here. So P is the focal distance. And that, again, is how far your vertex is from the focus or how far your vertex is from the directrix. They're the same distance, okay? Now, there's one other piece of information here, and that's this line segment that is parallel to the directrix, and it goes through the focus point. This is called the latus rectum, and it is equal to 4p. All right, so this focal distance, if we quadruple it, right, multiply it times 4, would be the length of that latus rectum. All right, and those are some of the pieces that we're going to use to graph our parabolas, just given an equation. All right, so that's kind of the breakup. You've got the x squared and x squared functions that can be concave up or concave down. The y squared functions are either concave right or left. A couple of things with the equations that I want to point out. And let's see. All right, I'll go with green here. So here's h. It's always attached to x. And here is k that is always attached to y. So your vertex for these problems, all right, is always the point hk. And if you are dealing with a positive 4p, you are going to be either concave up, or in the case of y squared, you would be concave right. And then in the case of negative 4p, you're concave down or concave left. All right, so those are kind of some of the pieces of information that we're going to be using to graph. All right, so in this video, I'm going to continue on to the next 4 questions, which are all about graphing. All right, and when we graph, it oftentimes helps to just list out some information and then use it to graph, or list part of the information and then use some more information to get it to get that information from the graph. All right, so I'm just going to focus on problem number 1 here. So things I notice, we've got x squared and we have a negative 4p value. That means that we are going to be opening down, okay? Your vertex is going to be the number attached to x, but remember it's opposite. So your h value is -2, your k value is what's attached to y here, but again, opposite value, so +3. Focal distance is the absolute value of this 4p. No, wait a minute, I lied there. Hold on, completely wrong. Sorry about that. What you want to do is take your value here, take its absolute value, and then divide it by 4. So you're always going to be dividing by 4, and whatever it is, because distance is positive, we're going to take 8 divided by 4. Your focal distance is 2. Sorry about that. There is a reason I was saying it was just the absolute value, but that's the length of the lattice rectum, not the focal distance. All right, so let's go ahead and use the vertex and the focal distance to try and start graphing part of this. So -2, 1, 2, 3 is right here. All right, now this graph opens down. So what I'm going to do to find my focus is to go down 2 units from where my vertex is. That's my focus point, and that point would be -2, 1. All right. My directrix would be the other direction. Okay. So I want to go up 2 units from my vertex, 1, 2, and now I need to draw myself a horizontal line. Okay. So I do still have a slight problem here in terms of graphing. Let me get the equation of the directrix here. That would be y = 5. Okay. Your parabola right now has 1 point, and 1 point does not define a parabola. It would help if we had a couple more. So what I'm going to do is go to my focus and basically graph in the lattice rectum. Now, the focal distance right now is 2. The lattice rectum, we're going to quadruple it, right? It's times by 4. And then basically that distance of 8, I'm going to put 4 of those units on the right side, 4 of those units on the left side, so I can get a couple more points. So 1, 2, 3, here's a point right here. 1, 2, 3, here's a point right here. So at least now I have a couple more points to go through, and it gives me the better shape of that parabola. So do your best to make a curve that goes through it. Remember, parabola is going to constantly get wider. All right. So what I'm going to be looking for is that your directrix, vertex, and focus point are all in the correct locations, and that you have these extra points to make sure that you have graphed your parabola accurately. Okay. All right, let's move on to problem number 2. We're going to go through the same process. Okay. But for problem number 2, I've got y squared and a +16. So this is going to open to the right. So this is a non-function parabola, but we can still do everything that we just did. So vertex, what number is attached to x? Well, there's nothing that's being added or subtracted here, so that's going to be 0. Number attached to y is -2, so I'm going to go ahead and pull a +2. Focal distance, I want to take the absolute value of 16 and divide it by 4. So that means my focal distance is going to be 4. So let's use some of that to actually start graphing this parabola. So my vertex is at 0, 2. I know this thing is opening to the right. So if I count 4 units to the right, 1, 2, 3, 4, there is my focus. So that would be the point 4, comma 2. Looks like there's a little negative in there, so let me take that out. There we go. And then directrix, I want to count in the opposite direction. So I counted to the right 4 units to get my focus. I'm going to count to the left 4 units to get my, in this case, the vertical line. That would be the directrix. Okay. And that vertical line would be x is equal to -4. Okay. So we've got the focus, we've got the directrix, we've got the vertex. We need a couple more points. So this focal distance of 4, I'm going to quadruple it, right? Multiply it times 4. That'll get me the length of the latus rectum. That's 16 total. So from the focus, I'm going to count 8 up and 8 down, which would get me the total length of 16 that I need for the latus rectum. All right, so from that point, that focus point, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. I just hit the top of that graph. And 1, 2, 3, 4, 5, 6, 7, 8. That I don't think I counted right. 1, 2, 3, 4, 5, 6, 7. No, I did count it right. All right. So now that I've got those points, we're going to notice that this particular parabola is very, very wide, which is, again, totally fine. Every parabola can be a little different. All right. So this equation, y minus 2 squared is equal to 16x, graphs into the red curve. The little green dot and the blue dotted line for the directrix are not actually part of the parabola, but they are key pieces to know how the parabola was made. So remember, this point right here is the same distance to the focus as it is to the directrix. Remember, that's how the definition works for a parabola. All right, 2 more equations here to graph, and then this video I'm going to close out. All right, so this equation, we've got y squared is equal to a negative, which means this is going to open to the left. All right, my vertex is going to be what's attached to x, what's attached to y. So -3, and there's nothing attached to y here, so it's a 0. Focal distance, I want the absolute value of this, and then I'm going to chop it into 4s, which means my focal distance is 1. All right, so vertex, 1, 2, -3, 0. This is opening to the left, so I'm going to go to the left 1 unit. There's my focus, which would be -4, 0. And then I'm going to count to the right 1 unit from the vertex, and that would be my directrix. Okay. My directrix is x is equal to -2. I need 2 more points. So take your focal distance, multiply it times 4. So that would be the length of the latus rectum. That's 4 units. So I'm going to do 2 units above the focus, 2 units below the focus, and that will give me my parabola. All right. So you'll notice this parabola is a lot narrower than the last one, but still it's pretty wide. I mean, all these parabolas are going to have slightly different characteristics. All right, problem number 4. All right, so we've got y squared, and we've got a +8, so this is opening to the right. Vertex, what's attached to x, what's attached to y, but remember to flip their signs, so 4, -2. I'm going to take the absolute value of 8 divided by 4 is my focal distance. That's just 2. All right. So let's see. We've got 4, -2. I said this was opening to the right. So I'm going to go 2 units to the right for my focus. So that's going to be 6, -2. From the vertex, I'm going to move to the left 2 units. Okay, and that's going to be x is equal to 2. The total length, sorry about that, the total length, All right, let's try this again. There we go. The total length of the lattice rectum is 8 units. So I'm going to chop that distance in half and go 4 above my focus and 4 below my focus. All right, so 1, 2, 3, 4. 1, 2, 3, 4. And again, draw in a nifty little parabola curve here. All right. So in this case, we did a lot of problems where it was opening to the left or right, just I think mostly because we haven't seen those in the past very often. As always, ladies and gentlemen, if you have any questions or concerns with these, please drop me a message in Canvas or send me a message through email, and I will help you out as best I can. In the next video, we're going to reverse the process and take a graph and turn it into an equation.